The Big Bang Theory was originally developed by Georges Lemaitre and based off of Einstein's theory of relativity. Since its development, it has been widely accepted in the scientific community. According to the Big Bang Theory, the universe was once in an extremely hot and dense state, comparable to fitting all of the oceans on Earth into a small water glass, which expanded rapidly. This rapid expansion caused the universe to cool, and, as a result, it continues to expand infinitely. According to the most recent measurements and observations, the Big Bang occurred approximately 13.75 billion years ago, which is thus considered the age of the universe. After its initial expansion, the universe cooled enough to allow energy to be converted into subatomic particles, protons, neutrons, and electrons. Over the course of a few thousand years, these particles formed basic, small elements on the periodic table, such as hydrogen, helium, and lithium. The Big Bang Theory was a major stepping stone in our understanding of the universe. From it, we have gained a much more reliable understanding of how the universe was formed, and have developed several new laws and theories to help explain other aspects of the universe. Hubble's law states that all objects observed in deep space are found to have a Doppler shift. The light wavelengths are distorted based on how a distant galaxy is moving, similar to the way a fire truck siren sounds different from the front than it does as the truck passes by. That can be used to detect distance. In simplified terms, Hubble's law states that the distance and velocity of all objects in the universe can be detected based on the change of wavelengths due to the Doppler effect. Hubble's law proved that other objects visible in the universe are not necessarily all part of our galaxy, the Milky Way, but instead they are often individual galaxies completely independent of ours. Although this may sound like an obvious statement, before Hubble's law was developed, there was much controversy over determining if objects in space are or are not part of the Milky Way. The Andromeda Galaxy was used as an example, and Hubble's law proved that it was in fact a separate galaxy. The Hubble Space Telescope was launched in 1990, and since then it has provided an abundance of useful information that has helped develop and improve theories of astronomy. The Hubble has helped to resolve some long-standing problems in astronomy, as well as turning up results that have required new theories to explain them. Among its primary mission targets was to measure distances to stars more accurately than ever before. It has proven the usefulness of Hubble's law. In addition, it has been able to increase the accuracy of Hubble's law by 20%. The Hubble Space Telescope has also provided the scientific community with sharp, high-res images of extremely distant galaxies that no Earth-based telescope could ever match. These images have allowed astronomers to gain a better understanding of how galaxies are structured, what holds them together, how they were formed, and many other key aspects. Through the information gathered about other galaxies by the Hubble's telescope, we have been able to gain a much greater understanding of the Milky Way as well. Through the use of new technology and new scientific theories, we have been able to discover and learn many new aspects of our universe. Through the use of space telescopes and probes, we have found that there are other planets in the universe that can possibly sustain life sometime in the future. Even in our own solar system, there is potential for life. Titan, one of Saturn's moons, contains many elements that Earth contained in its early stages that are attributed to the development of life. It also has an atmosphere very similar to ours. We have also been able to develop theories of black holes and wormholes. It is also partially theorized that with the use of wormholes, considering that humans were able to reach one, we might be able to time travel, that is, see Earth form such a great distance that it appears as though we were seeing the past. Supernovas, neutron stars, nebulae, planets, and other celestial bodies have been discovered as well. By studying these, we have learned much about the laws of nature and how our Earth was formed.